Okay, so first of all, let's just review what the abstract classes are very quickly. So we did the example about polygon being the abstract class, and then we got two concrete classes being rectangle and triangle. At the end of the lecture, once I introduce you to interfaces, I'll tell you when to use which. So we'll get there. Okay? Abstract class, so what is that? Typically, you got at least one method which cannot be implemented at the ancestor class level. For example, polygon. You simply don't know how to calculate the get area method at the polygon level. You have to delay that kind of implementation by declaring the method to be abstract. And then once you get to triangle, we'll go to rectangle, you can implement that method. Okay? And then we can also define some common implementation. For example, get parameter. We simply sum up the size using the single loop. And that loop can be shared by all the descending classes. Okay, that's typically the use scenario for abstract classes. Okay, now this is more like a review of what we talk about when we talk about polymorphism for method arguments or method return value. Okay, so now it is recommended whenever you got, for example, a choice, you rather declare polygon to be the variable type of P. So what kind of flexibility does it give to you? Imagine this, if polygon P is the left-hand side of any assignments, what can be the right-hand side? You got two possibilities there, right? It can be either rectangle or it can be triangle. On the other hand, if you only put rectangle P, in that case, you got only one choice on the right-hand side. So you want to be more flexible. Similarly, when you declare method arguments, you want to be polygon rather than just rectangle, right? You want to just give as many choices for the user as possible. Similarly, also for the return type, okay? All the similar cases. And then one more time, because the abstract class is actually abstract, got at least one method that's unimplemented, so it cannot be the dynamic type, as we said last time. The way we did it is proof by contradiction. You can review the lecture from last time. Okay, finally, so now once you, it's really about dynamic binding. So once you declare the variable type, the static type to be polygon, the dynamic type can be any of the descendant classes, okay? So you can review how we define this get polygon method from the previous lecture. Okay, now let's talk about interfaces. So once I'm done with abstract classes and interfaces, I'll give you a really quick summary, like when to use which. Again, it depends on your experience. And as you get more experience in Java, you would know when to choose which. So interface, the idea, let's just walk through the idea very quickly, and then we'll also do one example to illustrate. So now let's consider one problem. We are very familiar with the point problem there, right? Two-dimensional points. The way we did it before, we simply declare x and y being the two attributes. But let's make the story a little bit more interesting. So now, let's consider this diagram here. I'm gonna draw that on the iPad, okay? So first of all, there are two possible ways you can implement the two-dimensional points. So a little bit like a review of your math, okay? Let's do that quickly. Okay, now, let me just add a new page before that, before I do that diagram there, okay? So this is just one example. Okay, so now, how do we represent two-dimensional points? So there are basically two different ways you can do it. Let's say, for example, let's say in both cases, I'm trying to represent the same points. For example, you can see 2 points over here, 2 points over here, okay? So now the first system is called Cartesian system. Cartesian. And the second one is called a polar system. Cartesian system is very straightforward. If I want to represent this point using Cartesian system, I want to know what's the vertical distance and what's the horizontal distance, right? So now I can know that that's a horizontal, that's vertical. So I can simply get x and y. Okay, just x and y over here. Okay, that's Cartesian, very easy. The polar system is more interesting. That means to represent the same points, we don't really just use a vertical and horizontal system. We don't just use the vertical and horizontal distances. What we do is as follows. We know that what's the distance between this point and the origin. Let's call this r. And then we want to know what's the angle over here. Let's call that phi over here. Okay, so we got two things over here. Now, can you kind of see how can we know the coordinates for this point over here? If I know the distance from the point to the origin, I also know the angle. That's something you learn from the trigonometry, right? You can do cosine and sine, okay? So now you can see that what would be, first of all, what would be the x over here? So that's going to be basically r times cosine. That's fine, I got it wrong too. So just, you don't need to memorize this, of course. I just want to give you one example. Okay, for y, that'll be the vertical value here, so that'll be r times sine. Okay, now my main point is there are two different ways to represent the same points. That means you got two possible implementations for your code. But for both systems over here, they support the same thing. Okay, as far as the user is concerned, let me just write it here. As far as the user is concerned, you can think of this part over here below this is implementation. Implementation in the sense that for anybody who's using your code, they don't care which system you choose, they don't care. So what do they care? They care about how they can use your code. How can they use it? So if they want to just say, I want to get a two-dimensional point, I want to know its location. In this case, they only want to support two methods, get x and get y. And that's it. Now let's imagine this conceptually. Let's say the user say get x and get y. If internally I happen to choose the Cartesian system to implement, in this case, it'll be very straightforward. Return x, return y. Because x and y are exactly the two attributes I store in my objects. On the other hand, if somehow the user still try to say get x, get y, the same interface. Now, internally I happen to use the polar system. When they say get x, it's not really just about returning the value of the attributes. It's more about computation. The computation would be, when they say get x, it will translate into r multiply cosine, whatever the theta is, right? Sorry, not theta, sine. Here, and also get y, it'll be r times sine phi over here. Okay. Conceptually, any questions? And then once you get this concept straight, we can now see how the Java code works. It's very easy. Okay. Guys, no questions? Okay. Now let's do one example together. So now let's say this. So this is something you will see from my example. I want to illustrate to you. So the same point, this one basically is going to work. So now here A is simply some variable. A can be anything. A can be 1, can be 2, can be 3, or any number. Okay. First of all, you can see that it's basically a multiplied by square root of 3, and also a and 2a over here. Because you can see this is a right triangle. Right? You can see that if you do the square of the two sides, the sum will be equal to the square of the third side. Okay? Now, what I want to illustrate is, if we simply use, let's say we use a polar system, what's going to happen? The polar system, let me use proper color here. Let's say the polar system is going to be blue. Okay? For the polar system, what should we store for this point over here? We don't really just store the coordinates directly. We store 2a, the distance between the origin and the point, and also 30 degree. To be more precise, you want to store the radian of that, but I'll get there. Okay, you do have math libraries to support that. So that's a polar system. So now what about the, let's say, Cartesian system, the one you're very familiar with? Cartesian system over here. And for that one, let me use maybe pink over here. In that way, we store actually different things, right? We're going to store this value here and also this value here differently. But the point is, these two implementations, even though they're different, but the functionality they want to support is really the same. You want to get the location of the points. Okay? Guys, any question about this? Hopefully just simple math for you. Okay? Now, let's get to Java code. So once the concept is straight to you, the rest of the stuff is easy. Okay? It's only about some syntax to show you. Okay, you can read the rest. Okay, that's exactly the same diagram I just illustrated on the iPad. Okay, so now we're going to see that how we can, first of all, define two classes which will represent polar system versus Cartesian system. And also we have a common interface. So that's why we call the new concept called interface. Okay. Now let's see how we can do. First of all, from the user's point of view, we're going to declare something called an interface. Okay? And also example code is also available on the course website. You can also download it to try. So now we say that from the user's point of view, they only want to know how they can get x, how they can get a y. Internally, polar or Cartesian, they don't care. That's simply not their concern. Okay? Now you can see that what's really doing here. you can see that double get x, parenthesis, and then semicolon. You can see that's, again, the signature of the method. That's abstract. Remember what we said about the abstract class. At least one method should be abstract. In the case of the interface, it goes to one extreme end. Every method is abstract, every. Okay, what does that mean? That means when we declare this interface to be the point, it only contains signature of the methods. That means any class which wants to implement this particular interface, they got complete freedom as to what they want to do. They don't share anything from the code of the interface. They only share the interface, the signature. Okay? Let's say if I want to do Cartesian system, I only want to say define a class called Cartesian point and then implement this interface and do whatever I like. And then another class for polar point as well. Okay? Over here, so it's simply different method signature here defines how it can access the point. And then only signature. Okay, similarly to the case for the abstract class, because for the interface, again, it does not contain anything concrete. So that means you cannot use something like this. For example, if I say new points, point cannot be a dynamic type. So similar reasoning. Okay. Guys, any questions until now, just for the interface? So once we got this interface done, now you got complete freedom about which is this descendant class, how they want to implement get x and get y. Okay, I'll show you. So now let's say we have one class called Cartesian point. That's an easy one. So this is something you have seen already. Let's say we have one class, and this is a new keyword for you. In the case of the abstract class and normal class, you say extends. But now for interface, you say implements. Implements in the sense that since in the interface point, they have nothing concrete, no concrete implementation. So now we're going to implement that. Okay, Cartesian points. And now we got, so these two should be private actually. When you see the sample code, it will show you private. So we got x and y. So these are the things we store for Cartesian system. Okay, and then how do we support, for constructor, we simply initialize x and y, and then store the attributes. Now, how do we support get x? It's easy, just return x. How do we support y? Well, you return y. Okay, and that's it. So this class over here represents the Cartesian system, which I talk about over here. That's the Cartesian system. Okay, so now let's see another class which implements the same interface. Okay. Okay, you can just go over that. It's very easy. So now, because Cartesian point over here contains the code for every abstract method which is inherited from the interface. So now, you can simply use the Cartesian point as a dynamic type. I'll show you some tester in just a moment. Okay, second one. Second one is interesting. So now, let's say we got another class which also implements the points. It's called polar points. So now, what do we store if you review what we said? We're going to store something called r and something called phi, right? The angle and the distance. If you go back there, that's exactly what's happening here. So we have double phi, which is the radian of the angle. And then we also got r, which is the distance between the points and the origin. So these are the two attributes, as opposed to just x and y. And then to initialize the object, we simply pass the distance and the angle. And now, how do I implement get x? Any idea? R times cosine of phi, exactly. But in Java, you will see. So here, this is what I did. So R, first of all, and then it should be cosine of phi. Okay, that's what I did. Okay. The assumption is the phi over here is in radian. Okay. And also get y, you can see that sine. You can simply use a math library. Okay, you don't need to implement the cosine and sine yourself. You don't have to. Okay. Now you can see something similar. Since polar point implements all the abstract methods, so now you can use it also as a dynamic type. Okay. So now you can see, for example, you can say points. You can see on the left-hand side, I simply put an interface type, which is allowed. It can be the static type. Now the dynamic type is anything that is descendant class of the point. In that case, polar points, right? I just pass the, I'll show you how to do pi over 6. I'll show you that, okay? Okay, for math, you just want to know 360 degrees, 2 pi. Okay, just as a review for you. Any questions so far? Yes? You want to define some new method? Yes, you may. However, it's a very good question. The question was, hypothetically, let's say we say class polar points implements point, right? Let's say we define just a new method. Let's call it m. Okay, method m. Now, let's say if I say point P is assigned to new polar points, whatever, right? Now, can I say P dot M? No, right? Because P dot M, the static type of P is actually a point, which does not declare that new method just talked about, so be careful. You may want to do some cast if you really want to do this. Okay? But typically, if you really say you want to implement some interface, you don't necessarily want to introduce new methods. The interface itself should really tell you what's enough for the user. Okay? Okay, now, let's now see some tester. Basically, again, this tester here, I'll show you again, the diagram you should really look at is this one here. I'm going to basically say, I'm going to use a and also a square root of 3 and also, different parameter. I'll show you. Okay, you can see the a over here, which can be any number. So if you change that to be 1, 2, 3, 4, 5, or 10, the tester will still work. Okay? So now you can say a, and then x will be a square root of 3, right? You can see a square root of 3 over here, and also a, which is the y, which is over here. Okay? Now let's build up the things. First of all, let's declare a variable called p, and the static type is points, interface type. So now that means any class, any descendant class that implements this interface can be the dynamic type. Okay? Can be polar points or can be Cartesian points. Let's do, say, P is assigned to new Cartesian point x and y, right? Just x and y over here. And it's polymorphism because we are changing the shape now to Cartesian points. Now, if I say the following line, I say P dot get x and P dot get y, which version of get x and get y is it going to call? Cartesian point, right? Because of dynamic binding, depending on what's the dynamic type of P at this point, which is Cartesian points. Now, let's say I change the shape of P to be polar points. You can see the way I initialize the polar point is a little bit different. First of all, I'm going to say 2 times A, right? 2 times A over here. That's the distance. And then I'm going to pass the angle. The angle is 30 degrees. But I'm going to convert that into radian. So you can simply use math.toRadians. So that's something that's supported in the math library. Okay? Again, that's polymorphism. You're changing the shape of P from Cartesian points at line number 7 into polar points in line number 9. Now, if I make exactly the same call over here, you can see line number 8 and 10, they're identical. However, different versions of get x and get y are called, right? Now, in line number 10, which version am I calling over here? In polar point, right? Yes, good. Exactly. So now you will call the polar point because at the point of line number 10, the dynamic type for P is actually polar points. It's been changed. Okay? Okay. So you should really know why polymorphism and dynamic binding. Whenever I talk about polymorphism, that means I'm changing the dynamic type. Dynamic binding means depending on the current dynamic type, it's going to call different version of the same method. Okay, now let's summarize what interface does. Okay, that's it. Interface in principle is very easy. It's not that complicated. So now we say that interface, all the methods have no implementation bodies, only signatures. So in some way you can think about interface is an abstract class where all the methods are abstract. That's one way to think of it. And then, so that, what's the benefits of that? That means any class who wants to implement a particular interface, they have complete freedom. They don't have to get any legacy from their ancestor. Okay, that's kind of intuition. Okay, so now similarly, you should really try to use interface as a static type whenever you can. For example, if I put point P over here, what can be on the right-hand side of the assignment? It can be Cartesian, it can be polar. On the other hand, if I say Cartesian point P, in that case, I can only put Cartesian point on the right-hand side. I cannot put polar points, right? Because polar point is not a descendant of Cartesian points. Similarly, I should also put the interface type as method arguments, and also for return type. Okay. And of course, you cannot do the interface type as a dynamic type. Okay, guys, any questions? Yes.
What's the key difference between abstract class and interface?
That's exactly what this slide is going to tell you.
Okay.
Very good. That's very good questions. Yes. Mm-hmm. But I would say, I'll try to go over this slide to see if you still got any more confusion. But I would say, again, try to study these two examples to really get a feel about when to use abstract class and when to use interfaces. But I would say, again, when to use which, there's really no right or wrong answer. Possibly when you get to 3311, you will see more. But I would say it really up to your experience. But I would say maybe in your 2011, whenever they're introducing you to a new ADT, data structure, it's going to be, for example, like an interface. And then for a particular ADT, for example, stack, I'm going to show you one example in a moment. You got stack being an interface. How many possible implementation can you have for stack? It can be, for example, we talk about 3, right? It can be either an array, or it can be a singly linked list where the front is the top, or it can be a singly linked list where the end is the top, right? You got 3 possible implementations, right? Okay, let's review this slide quickly and then to see if we got any more questions. So now you want to use interfaces when you have common set of functionality, for example, get X, get Y. And then you want to allow for a variety of implementation strategies. Right? For example, for get X and get Y, you can either use polar system or Cartesian system. Okay? And then each descendant class, they actually got a different implementation strategy, right? It can be either polar or Cartesian. They're completely different. Okay? Okay, either Cartesian or it can be polar. Okay, that's about interfaces. Okay, you can see you got the key thing to consider is you simply got a common set of methods to be implemented in a variety of different ways. Then that means you use interface. No sharing. They only share the signatures. Okay. What about abstract classes? That's a little bit like a mix, like a gray area. So now let's see this. So that means some, not all. Some implementation can be shared. For example, get parameter can be shared between rectangle and triangle. And also some other methods may not be shared. For example, the way you calculate get area for triangle cannot be shared by the way you calculate for area for rectangle. Okay? And then, for example, for polygon, you can see you can have get parameter to be shared and also get area not to be shared, right? It's going to be depending on, you got to delay that implementation to the descending classes. Okay, that's the principle. Guys, any questions about abstract classes and interfaces? Okay, if no, I'll move on to a new topic. That'll be the last topic for this semester. Last topic, generics. Okay, just give me 30 seconds and I'll get it ready. Okay, generics, and then I'll wrap up the subjects. Okay, generics, I got quite a bit of slides, but I think the main idea is actually in the beginning, about 10 slides. Once we get it through, the rest is just examples to show you, to reaffirm the ideas. Okay, now, exercise, okay? The best way to motivate you why we need generics is by considering something that does not use generics and that something there is bad, okay? Let's try. Let's say we are trying to define a class called book, okay? And then I gave you an idea. The book is a little bit similar to the map that we talked about before, right? We got keys and we got values. Let's say this. We got a book which is going to store records for a different person. So we got names being a string array, and also we got records. So the record itself can be anything, right? So because it's anything, we want to be as general as possible. What can be the most general static type? Objects, because objects is the top in the hierarchy. So we say that the records can be birthday, it can be phone number string, or can be anything, okay? So what's okay? Okay. Now let's say dot 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 here, that means you got to do it, okay? In the sample code, I'll leave that as an exercise for you. Let's say we have mutator here, we can add some new name and record pair into the book. So you can see the name is always string, but now the record is an object. So now we can add anything into the book, okay? Birthday, it can be telephone number or whatever. And the second one is an accessor. Because we know that we can store any objects inside the book. That means when we retrieve something from the book, it can also be anything. That's why it's objects. Here. Guys, any question about this book class over here? I want you to pay special attention to two things. First of all, line number 5, the parameter type for records objects. Second thing, line number 7, the return type for get is object as well. So these are the two critical things. You can see we are just trying to make things general. to be as accommodating as possible. But let's see what the problem might be. Now, let's consider a tester code for that. Okay, tell me which line you think got some compile time error. I can tell you this at least one line. Okay, or if you believe there's no compile time error, you can tell me as well. First of all, let's declare two variables. Let's say date is a library class in Java util, birthday, and also string telephone number. So that means we've got two kinds of records we want to store into the book, telephone number or birthday. And then we got the book B, which is going to be this type book over here. And also it's Wednesday. Okay, I'll show you how to use that in just a moment. Okay, we initialize a new book. Okay, line number 4. Phone number is going to be whatever this number is, string. The birth, now let's say we add the phone number for Suyang over here. Okay, line number 5. Sorry, line number 6. Okay, and then line number, beg your pardon, for line number 5 we add the telephone number for Suyang. Line number 6 we create a birthday object. So that's this year, month, and day. Line number 7, we are trying to add a second record into the book. You can see that we're trying to add for Yuna and then birthday. You can see the birthday and phone number, they're different types, right? Okay, that's something to think about. Line number 8, I'm trying to say, I know that Yuna has been stored for her birthday inside the book. So I say b.get Yuna, that should return back to me her birthday, right? And then get day. What does get day do? It's going to give you some integer between 0 and 6. Sorry, between 1 and 6. Basically, 1 means Sunday, 2 means Monday, etc. Okay, and then Wednesday means 4, right? Starting from Sunday being the first day of the week. Okay, so once we get a day for Yuna's birthday, we want to know if that's a Wednesday. That's why you see it's Wednesday here. Okay, just simple tester. Okay, any question about the code itself? Anything not clear? Okay, now let's now go. I will just use iPad here. Now tell me again exactly the same thing over here. The first block over here is the book, and the second block is the tester. Tell me if you think this will be any compile time error in here, or you think that's okay. I heard line number 8. You can line number 8 as well. Okay, anyone else? You can be different, right? That's fine. It's okay to be wrong. Okay, anyone else? Okay. Now, line number 8, well, you know what? What about this? Let me question you. Why don't we consider this line first? Do you think this line is okay? Okay, why does it compile? First of all, what's the static type for B? Book, right? And then it's add defined. Yes, so this part is okay. And now Suyang over here, because the first parameter is string, so that's fine. And then the phone number here, this is interesting. The phone number here, what's the static type for phone number? String, thank you. And then what's the static type for the second parameter? Object here. Now is string a descendant class of objects? Yes, good. That's why it compiles. Similarly, try to apply the same reasoning for yourself over here. Because birthday is of type dates. Date is also descendant class of object as well. Every class is descendant class. That means you can add anything into the book. Okay, now line number 8, I can tell you there's something wrong with it, but which part? Okay, I'm pretty sure you know. How about I let other people try? Okay. Anybody want to try? Yes, go ahead. Line number 8.
It's trying to call get day.
Mm-hmm.
That method.
Yeah.
Type of object.
Exactly. That's exactly right. Okay. Let's break this. That's exactly right. So now let's break this expression down into two parts. First of all, when we say b.get Yuna over here, so now think about, again, we talk about compilation, talk about static type. What's the static type for b.get Yuna? Object, right? That's exactly the return type over here. Okay. Static type is objects. Now the question is getDay a method defined in the static type? Nope. Does not compile. Okay, are we okay? So now, what does this mean? Let's think a little bit more abstractly. So there are two operations you're doing for this book. You can either store or you can retrieve. When you store, you can store anything inside. However, when you retrieve, the thing you can assume on the thing that you're retrieving is very minimum. You can only assume that the thing I retrieve is only an object. So that means if I want to call any method specific to the dynamic type of this object here, I need to do instance of check and cast. Okay, does it make sense? Okay, nothing really new. We are still reviewing, but this will lead us towards generics. Okay, that's good. Okay, let's go back there and then let's see. Okay, that's pretty much the same. Pretty much said everything already, except that you can do a cast over here. Right? You can say we have b.get UNA here. I want to cast that into a dates, and then say get date. But to be more safe, I tell you what, if you do something like this will also compile. Look at that. When I say b.get Suyang, remember what we stored into the record for Suyang? It was a telephone number, a string, right? So now, as far as the compilation is concerned, because b.get any string is going to return you an object static type. And then you can cast objects into date. It's a downward casting. So that's always compile. Okay? However, if you try to execute this line over here at the runtime, you're going to suffer from class cast exception, right? Because the actual dynamic type is actually a string. You're casting a string into dates, because string does not support any get date method, so you cannot meet the expectation. Okay? So the best way for you to do it is instance of, right? You can say b.get Suyang, so that's just one expression. So from the lecture before, we simply just put a variable name over there, but in general, you can put any expression you would like to check. So we are going to check that whatever the return type, return value from b.get, in this case Suyang, that will give us a string telephone number. Is string instance of dates? No, false. That means we're going to bypass this dangerous cast, right? Guys, any question about this? Okay, nothing new yet. I'm just trying to bring a different example to show you. Okay, so now what it really says up to now, if you have a general book in the sense that you can store anything into the book, and then why I call it general is simply because you can see that over here, I'll highlight that. The type of each array element, the static type is simply just object, so it's very general. That's the most general thing you can have. Now, they seem to work. However, there is some problem for this from the software design point of view. Okay, programmatically, what we just did is going to work. However, the problem is this kind of solution, a combination of instance of check and also cast, is not going to scale. Which means if I give you a very big project with 100 classes, you cannot apply that solution. It's going to be too tedious. It's going to be too difficult to keep track of. Okay? I'm going to show you why. Okay? Now, I'll give some idea. Okay? Now imagine this. Let's say we have a large number of record types that we may want to store into the book. It can be dates, string, person, account, my utilities. It can be assessment, grading components, whatever classes you have seen so far, anything. Because the static type for the array is simply just objects, so anything can be stored into it. So now, what can be the problem for this? Okay, let's see. Okay. So now let's imagine the following. Let's say we're gonna have a book where we're gonna have 100 different record types, different dynamic type for that. Okay, I'll give you some sketch, the idea. Okay, for example, let's say the first line, I simply say the left-hand side is simply an object over here. And then on the right-hand side, anything should be okay, right? Let's say we have a class called C1, any class. It can be person, can be scanner, can be whatever. And then you can see C1 is a descendant class of object, so this compiles. And then when we say add some string and then record 1, this should compile as well, because the static type for record 1 is actually objects. Object is a descendant class of the parameter type, which is also objects, right? So this compiles. So this is C1. Let's say I add another record 2, where the dynamic type is different, C2, just different, anything that's different. I keep going, and then I simply add 100 different records, and all these records have different dynamic types, up to C100. Okay, guys, follow so far? Okay, and now let's say this. If now I retrieve some objects from the book, how can I actually know if that is of a particular C1, C2, or up to C100? How can I know? In general, you just cannot know. All you got to do is you have to have some exhaustive check, if conditional, to say if the thing I retrieve instance of C1, I can now cast that into C1. If the thing I retrieve instance of C2, and then I can cast that into C2, and etc. You need a if then else statement of size 100. Okay, that means we got that. That's only for the case where we got 100 different dynamic types. For realistic product, you might got 500 or 1,000. You cannot afford to write such if conditional list every time. Okay, let me just give you an idea over here. So now let's say this. Let's say we say b.get Jim. So now from this context here, do you have any idea what the dynamic type for Jim is? You don't. Well, that's why the best thing I can say is it's an object. Now, how can I know if I can call certain methods on record? Well, I got to do instance of check. If record instance of C1, then I might be able to cast that into C1 and call some method 1 that's specific to C1. I got to say else if, and then maybe record instance of C100, you got to do 100 such thing, right? To really see what's the dynamic type of the retrieve value, and then do the corresponding cast. So now, this last rectangle box over here is really the consequence of this initial design. We simply have a book of objects. Okay? We can store anything into it, but when you retrieve something, if you really want to do something useful with the retrieve value, you got to do instance of check and cast. It's non-avoidable. Okay? Guys, any questions up to now? Okay? Again, this slide here just to illustrate to you, the solution we had initially is not really a wrong solution as far as programming is concerned. But from the software design's point of view, it's not good. It's poor design, very poor, because you got lots of instance of check and cast. Okay. Now, the question is, what should we do? Well, it's generics. Okay. Generics solve exactly this kind of problem here. So now let's just sketch what a solution should be. Okay. So we need a solution such that, first of all, we don't want to have any explicit instance of check and any typecast. We just don't want those tedious error-prone if-then-else statements. We just don't want them. They are not useful. And then we don't want any class cast exception either, right? The reason that we put instance of check in the first solution was because we want to avoid class cast exception. Now, not only that we want to get rid of those instance of check, we also want to avoid class cast exception. So both can be achieved. Okay? So now, this is how the solution is going to look like. Okay? I'm going to go back and forth and then to show you how the solution can be applied. Okay? Now, first of all, from the user's point of view, okay, let's read the principle first and I will illustrate to you right away. From the user's point of view, whenever you want to say, I want to declare a variable of type book, not only that it's the book, I want to commit at the same time what kind of book. Is it a book of accounts? Is it a book of person? Is it a book of telephone number? Okay, so you want to commit the record that be stored at runtime. So what does that mean? I'll switch back to the original design over here. Okay, I'll show you exactly what I mean. Again, you should really notice that this part here is supplier, right? That's where we define the book. And this is the user or the clients. Okay, the first idea over there to say the user, they must commit when they declare. So what does that mean? I'll show you. Now you can see that this line over here, we have book B. Okay, we're gonna change that a little bit. Okay, when they declare over here, they're gonna do the following. Let's say we want to do a birthday book. We're gonna say book over here, and then angle brackets over here, and then we're gonna say every element in the book is gonna be of type dates, and to be more precise, any class that is a descendant class of dates will be okay. Okay? So that's the first idea. So that means for me as a user, when I declare the book, I have to commit right away to say what kind of element am I going to store in my book. If I want it to be telephone number, I'm going to say book and then put string inside rather than dates. I got to choose one but not the other. No, but not both. Now let's draw some connection to what you learned maybe back in 1022. I think they kind of show you how you can use array list or linked list, right? That's how you use them. But now you should see why. Because every time when I say array list of, for example, person, I put the person inside angle brackets. That means I'm committing to the compiler to say, I will only store person into this array list, nothing else. The same idea. Okay? But the way I teach this is I will try to show you what's the story before this, right? Okay, that's the first idea. On the client side, they got a commit. I'll just say that's number one. Okay? What about the second idea? Okay, so now the book store only dates, but not string. Okay? Second idea. So now, when you are trying to store new record objects into the book that you just commit, so now you can only store the descendant classes to it. Okay? But what if you try to store something that is not a descendant classes of that? What would that be? From before, in the case of the object, you will throw some class cast exception if you cast to the wrong type. In this case, compile time error. How? Let me show you, for example. Let's say over here, you can see that we say that everything you store into the book must be dates. So now let's review two lines. I want you to look at line number 5 over here, and also line number 7. Do you think both lines should still compile? In the initial design, which is bad, both compiles, because string and dates are both descendant classes of objects. But now, do you think they will still both compile? No, right? Because which line? 5 or 7? Which one doesn't compile? 5, right? Because, let's see why. The reason is, okay, if you look at the phone number over here, you can see the static type is string. Now you can see that string, is that a descendant class of dates? No. No, so it does not compile. So this line no longer compiles in the new design, which is good. Because now we don't want to be so accommodating when we accept things to be stored. Only the things that user commit to. Okay? On the other hand, line number 7 over here, we have basically birthday over here, the same reasoning. Because the static type for a birthday over here is date. And date is a descendant class of dates, so that's okay. Okay? Okay, that's the second idea. Okay, I'll just say second over here. Okay? Now the third idea. So now, so we just talked about storage. So now we got more constraint mechanism for storing things into the book once we apply this solution here. And now let's say this. Since we're being so careful about storing things like a date only into the book, now when we retrieve something from the book, can we make more assumption about what we are retrieving? Of course we can. Before we couldn't, simply because everything can be stored, just objects. But now, since we know that in line number 5, in cases like line number 5, we simply wouldn't allow anything other than dates to be stored. So that means when we retrieve things from the book, it's dates only. Okay? So now, for point number 3, let's review this line over here. Oops. This line over here. Again, this line here in the previous design did not compile. What about now? Should it compile? It didn't before. Okay, now you might be hesitating because you haven't seen the complete story, especially for the book. I haven't illustrated that yet, but I'll do. But now intuitively thinking this way, Now I'm going to put it here. Intuitively, we know that because only dates can be stored. So that means only dates will be retrieved. Okay, that means what we can assume about b.getUna is going to be a date for sure. So that's why we don't need to do any instance of and check, instance of and cast, not anymore. It's simply because we are being more disciplined in terms of accepting things to be stored. So now when we retrieve something from the book, we can make more assumption about it. Okay? But now, line number 8, let me save a little bit for that because we want to see more in order to judge mechanically. Okay? Let me go back there. Okay, so these are the points here. So now, let me, before I go back to the book, I want to talk a little bit about parameters. Okay, this word over here. Basically, you learned about parameters a long time ago in mathematics. Okay? Basically, whenever you want to define a function, you think about what should be the parameter for that. For example, let's say I want to define a function for addition. I got 2 and 3, 1 and 1, 10 and 10. 10 and 101. So these are the argument values. So now, when I want to define a generalized version for the addition, so I want to say I can accept anything on the left-hand side being an integer, also anything on the right-hand side being an integer, right? So I can say, now, this is what I can define. I can say plus is a function. It's going to take one integer, and return an integer, right? I'm just generalizing the thing, okay? So here we talk about argument value versus parameter. That's in mathematics. What about in Java programming? We talk about parameters for methods, right? So now, how do you design the types for your parameter? In this case, for example, if I know that whenever I say deposit for account, I always gotta pass an integer, for example, like 123 or any integer. In that case, I can simply define a method like this. I can simply define over here. I can say deposit and then integer amount, right? So I'm just generalizing what the argument value can be. Okay. Now, how do we apply this idea into what we just said before? Okay, let's see that. Now, let's go back there. I want to do something about this book class over here. Okay, book over here. So now the idea is we want to parameterize the type for the elements in the book, okay? Rather than saying they're simply just objects, that's too undisciplined. We want to say, we want to use a parameter, for example, any parameter, like an E, for example, to say the type for this particular book is going to be E. And somebody else is going to tell me what the E should be later. Okay, let me just tell you how to define this. From the supplier side, you'll simply do, over here, you would say book over here, and then you just got to use, usually the Java convention is just use E for elements. Now, let's compare these two things. If you see what's going on here, when I say book E versus book dates, book E happens in the supplier side, and book dates happens in the user side, right? What does that mean? That means when I'm the supplier for the book, I am making this E over here unknown, which means it's going to be committed later. So that means whoever is using my book class, they have to commit what E should be. In this case over here, you can see that it's really committing E to be the dates. Okay, let's see more. So now the advantage for this thing over here is once I declare this parameter type over here, I can use it throughout the definition of my class. So now I can replace every occurrence of objects by just E. Okay, I can replace this by E. I can replace this object over here by E. I can also replace, oh, not this one. Also replace this one over here by E. Okay? Let me make it, do I have any more? Okay, that's fine. Okay. So now you can see that I'm going to show you the clean code in the slides, and then I'll show you how things will work. So now, line number 1. So now class book, and then it's parameterized by E. Okay, and then also we got string names, and now we have E type rather than objects. Okay, and then we have the record type over here is also E. And then we have the return type also being E, not object anymore. Every occurrence of object has been replaced by E. And also, at the class declaration level here, we declare E over here. That means this E here is unknown as far as the supplier is concerned. They don't care what E is. But later on, when you're trying to use the book as a client, you have to tell the compiler what E should be, so we can do the proper checking. Okay? So now let's consider, well, that's also something I've shown you already. Okay? Now over here, I want you to look at line number 2 over here. Okay? Now what's the consequence when I do line number 2? Okay? Now I want to just use a new diagram here to show you. Okay? That's really important. Okay? Image. Maybe moments. Okay, over here. Okay? Now let me just write down very quickly. So now the generic parameter is simply E over here, and then this one over here is E, and this one over here is also E, and this one over here is also E. So now let's think about from the client side. From the client side, if I say book, and then let's say dates over here, And then I would say birthday book. So what's the consequence of declaring this line? That means now, from my point of view as a client, I'm making it known to the supplier, right? So every occurrence of E is going to be replaced by dates. Every occurrence of that. So that means for this particular BD, so now what's the static type for BD.get? In this case, dates, exactly. And it's easy for the compiler to see, okay? There's some program, that's been done, okay? Now, let's see another one. Now, let's say I define another book. Let's say book over here, I would say string for telephone. Let's say telephone book, TB, over here. So now what's the effect to the compiler? That means I'm gonna replace every occurrence of E by string. String here, and also string here, and also string here. Okay? Now, when I say telephone book dot get over here, what's the static type? String, right? Yeah, exactly. You can see that. So it's really critical. The compiler actually basically look at what you commit that into. Once it is decided, it will be replaced throughout the definition for the original code. Okay, that's a very quick walkthrough of how generics works. But you can see that the benefits of having generics is you don't have to have any instance of check and also typecast. That's really the benefits. Okay? So now, observation here, basically exactly what I said. So guys, any questions? Okay? I'm only 3 minutes away from finishing this topic. 3 minutes, well, maybe 4. Okay. Question for you, just to see, there's a question to think about. Now, let's say this. I do have a generic book, and the E is unknown. I can instantiate E to be anything. Now, if I instantiate that to be objects, is that good or bad? Why? How bad was that?
It takes us back to square one.
Hmm?
It takes us back to the beginning.
It's bad as in the beginning. Can you try to elaborate? Why? So you're exactly right. Basically, what you're trying to say is, even though we are syntactically using generics, but the consequence is we are as bad as the first design, just like a book of objects. So now, if I want to store something into the book, so what can I store into it? Anything, right? Anything that's the descendant class of objects. Now, if I retrieve something back, it's a mess because it's only an object I can assume, right? Because the type I commit to is only objects, right? Think about this example here, okay? It tells you gotta be careful when you use the generics. No, okay? That tells you don't do it, okay? Okay, guys, I want to just summarize the topic by giving you 2 examples, okay? Very quick, only taking 2 minutes. So basically, what I want to show you is, remember we talked about singly linked list and also stack before. Whenever I talk about the elements for these 2 data structure, I simply put string. However, in some way, any collection can be a stack, can be a queue, can be a singly linked list. Any collection can be generic in the sense that it does not really matter what kind of stuff you store into it. It only matters how you retrieve them. You might say, I want to retrieve like a FIFO style, right? Last in, first out, or first in, first out. That's really the main thing. But if you want to say the type of the elements that's stored there, it doesn't really matter, okay? That's why you can make it generic, okay? To make story short. Now, let's see how you can refactor your design for the singly linked list. You will see that's amazingly easy, okay? You can see that I simply replace almost everything. You can see. Now, I used to say node only, and then I will put string elements. Nope, now I simply just put E over here. Okay, I can replace every occurrence of string just by E, like how I replace every occurrence of objects by E. Okay, and then for singly linked list as well, I also make it generic. Okay, now of course I'll leave that to you to study the code. Okay, and then if I just want to do approach 1, approach 2, there's only one thing I want to show you as a syntax. Now for the clients, I'm committing the node, the element type to be a string, right? And then this is the thing. When you say new node, you have to somehow, you got 2 options here. You can, okay, I'll just show this something to you quickly. Okay, so now you got two options here. You can either say node, string. Let's say n is assigned to new node, and then string. So this is one option here, okay? Oh, actually, let me just be consistent with the slides. So this is the element which is Tom, and then the next element is simply null. So this is one version of that. However, if you really mean this type here to be exactly the same as this one, you can omit that type. The compiler would be smart enough to figure that out. So that means number 2 is also fine. If you say node, string, I can say n is new node. Leave it empty. And then you can put Tom and null over here. So both work. When you see the example code, you will see that. Okay. Okay, now let's go back. Okay. Now, basically, that's how you define each of the methods in a generic class. I would encourage you to look at the example code. Okay, I simply say now, rather than taking string, I'm taking E, right? Huh? In some way, yes. In some way, right? That's how we did from the first design to the second design. Yes. Okay, I'll leave that to you. You can algorithmically, they are really the same, but you just change the type. Okay, now one more example, stack. Now, I want to show you interface. So I'm defining an interface called stack. So what do you want to support for the stack? As far as the user is concerned, the only worry about size is empty, top, push, and pop. Right? Now I make the stack to be generic over here. And when I say top, it's going to return whatever E it is. And also pop is going to return whatever E it is. Right? And now, this is the architecture. I want to have an array stack where I'm going to have also generic. Okay. Also, I'm going to have another link stack. So it can be linked list or array implementation. Both of them implement a stack. Okay. Pretty much like polar points, Cartesian point, both implement this, the points. Okay. Pretty much like before. Now, for the code, you have seen them already. Again, it's only about substitution. I tell you what, if you compare this slide of code with how I implement array stack as before, first of all, I declare the generic parameter over here, first of all, and then replace every occurrence of replace every occurrence of string by E. One more detail to show you. Look at this line over here. Unfortunately, if you want to say the array itself is generic over here, E. However, if you want to create a new array of generic type, you're going to say object array and then cast that into generic parameter. I would say for this line here, you don't have to worry. I'm not going to ask you this line in the exam. However, for your later project, you may want to know this line. Keep it as a reference for you. Okay. Okay. Now you can also do link stack, in which case you just use linked list. You can now see that we declare an attribute data, and then that's also simply linked list E. Okay. And then you can just do everything else the same. We're just treating the first as a top. Okay. Again, we replace every occurrence of string by E. Okay, now one final slides, final one. Now, how do we actually test this? So now let's say we have a stack of string. So now in the client side, we're committing what it should be. It should be a string. And then let's say the dynamic type for now is array stack, polymorphism, right? Array stack is an interface. Array stack is some implementing class, okay? And now if I say s.push, which version is it going to call? Array stack, right? Because of dynamic type, okay? s.push, and then I can just do some assertion. And then s.top is also going to call the array stack version. Now, let's say I change the shape of s from array stack into link stack. Now, if I try to call exactly the same sequence of methods, because of dynamic binding, I'm going to call the same method, but it's a different version in other classes, right? For example, in this case here, I'm going to call the version in link stack, right? Because dynamic type is different. Okay, nothing contradicting. Okay, if you want to learn more, you can simply go to this website. That's the official website for generics for Java. Okay, guys, any questions before I wrap up? Okay, good. I think we're doing okay with the time. Okay. So the two more things I want to do, actually 3 more things I want to do. Okay. but they're light. Give me one moment. I'm going to do the wrap up, and then I'll tell you what the second thing is. Okay. First of all, I just want to somehow to tell you what we have learned so far, right? We have learned quite a lot, hopefully, in this course. So what we have learned. We have learned about procedural programming in Java. We started with utility classes, right, in week 1. And then we talk about recursion. Recursion itself is not really object-oriented. I would say it's usable for C, for any other non-OO language as well, okay? And then we talk about data structures. We talk about quite plenty of them. So we got arrays, just a review, get more deeper insight. We got maps and hash table, roughly, right? Well, you get more deeper insight into hash table in 2011. Singly linked list, stacks and queues, binary trees. Okay? That's what we have learned. You'll learn maybe about triple the times, maybe in 2011. You'll learn more. Okay. What really is really important about this course is object orientation. So we'll cover a lot really in this topic. This may not be an exhaustive list. So classes, attribute, encapsulation, objects, reference, data types, and then talk about methods, and then we talk about dot notation, how you can do something, dot something, dot something, dot something, right? Aliasing, make sure you know that for the exam. Inheritance, we cover also a lot about inheritance. I'm pretty sure we cover maybe more than, well, I would say more than anyone else, but definitely a lot. Okay, we got code reuse, right? We start with that, and then we build up the story from there. Expectations for static type, and what's the difference between static versus dynamic, and substitutions, right? That's kind of the intuition behind. So we got casts, we got instance of. Polymorphism, we cover polymorphism in method argument return values, right? Also, we talk about dynamic binding in terms of overriding. So these are the things. So these give you a checklist of your for you to prepare the exam. Abstract classes, interfaces, and also generics versus collection of objects. Okay, so these are also keywords we cover as well, okay? Okay, so finally, we also learned more about Eclipse. One thing I really hope you will practice more is breakpoints and debugger. So trust me, it's really your friend when you go beyond this course. Okay, also unit testing. Okay, so what about beyond this course? I would like to make just a little 3 suggestions to you what you can do. It's completely optional, okay? First of all, I would recommend this book here. This book, you're actually going to buy it eventually anyway for your 3101. It's an algorithm book. Why do I recommend it? It's not because I wrote it, no. No, it's because it's a good book, right? No, I didn't write it, by the way. I didn't write it. So basically, the book, the way they present is data structure by data structure, algorithm by algorithm. And the thing is, they only give you mathematical analysis and also pseudocode. It's not Java code. That's a good thing. So what you should do is, pseudocode means it's simply written in between English and code. You will see. I want you to do the following practice for each one of them. Read the math, read the pseudocode, translate it into Java, write JUnit tests. If you can finish this book by the end of your graduation, that'll be awesome. Not by winter, that'll be too soon. It's not possible. Okay, second one, very quick. If you want to practice more about object orientation, design, polymorphism, dynamic binding, there's a book which is like a reference book for 3311. For that one, I would say go over that. They got lots of design pattern in the sense that we got recurring problem in the industry, and we actually solve them by some existing solution or pattern, right? So it's actually, again, problem by problem, pattern by pattern. Okay, again, understand the problem, read the solution. I believe the solution may be written in C++, not Java. Translate and test. Final thing, I also teach software design. So if you want to see my lectures, feel free. I also got recordings there. Okay. Design by contract, design patterns, and program verification. All right, finally, wish you all the best. And then for 2011, you will be assumed everything that you learned in 2030. Okay, so don't abandon Java. Okay, and then if you got